20% basically, which is a better thing to do, right? And we multiply that by this, so we have 452.4 kips times 0.205, and this winds up being equal to 92.66 kips. I think I'll buy that. Yes. A little over 10% would be 45. 20% would be 90. It's a little over, okay? I do reality checks because I screw up my calculations otherwise. Okay, we buying that? Okay, so I need to put a force on this edge over here. Right, we go back to the model. Put another force on the edge. Right, we're going to put a force going this way, and I'm going to have to select the direction, and I need to have some reference. I'm going to delete that, clear the selection. I'm going to put U as a reference, and I'm going to go in the axial direction because that's the way we want it to work. Right, and it actually kind of looks like it's going in the right direction. Color contrast is not, but it's kind of like going in the right direction. And we want to put what, 92,660. Okay, so I got big force on there. And we can go ahead. I think we already created the mesh, but we can of course do it again. I'm going to take it up a little bit more this time. Okay, and we can run this study. Not sure I like that. Well, it got real high stresses around the corners.
Yeah, it's because the arc is too.
Yeah, the arc is too small,
It's too
right?
small, yeah.
Now, we got some high stresses around the corners, but do we believe any of them? Well, boy, I don't know. You kind of look at them, right?
I will.
It looks like there's not a whole lot of nodes in this
Exactly.
area, right? There's not a whole lot of the things. We can look at the mesh, and if we, I don't know if I can show the mesh in this one. There it is. Right, see, don't have a whole lot of points. Only got one point in the middle of the arc that I'm calculating, right? And where's my stress is gonna be? They're gonna be in these corners,
Yes.
right? So we're gonna need some more accuracy in there. So what does that lead to? Mesh control. Mesh control, yes. We can go control freak here, right? Okay, so what I'm gonna do some mesh control, and I'm gonna pick on these corners, right? Because I want mesh control, right? And they give me some parameters. Right now they're putting the nodes about 1 inch apart. I crank that up, and they're only gonna put them 3/4 of an inch apart. Now I'm gonna squeeze them down to where I want them about 0.2 inches apart. Right. We're gonna put some nodes in there. Okay. We can, because might as well, right? And if we really worry about, we probably might want to put some on these guys too. That wasn't quite so bad, but let's go ahead and remesh this. Yes. Okay. And now you see what it did is it put a whole bunch of nodes in these areas. You guys see that?
Mm-hmm.
Okay, I hope it shows up better for you than it does for me. I got a real bad angle on it. So, okay, so it's we get lots of nodes in that arc in there, we can run this and see if it's happier. Stress has got, I'm not sure if the stress has changed a whole lot, right? But they sure show up in the corners, right? We see we don't have stresses this way, or at least not very much of them this way. It doesn't look like there's a whole bunch of them that way, which to some extent doesn't surprise us. In a pressure vessel like this, which way is the big stress?
Radially outward, normal to the skin.
It's in the skin. Which one's the big stress?
Is it the hoop?
Trying to blow the ends off, or split the hoop, split the thing up. Blow it apart this way, or are we trying to blow the ends off? Which one's the big one? One of them is bigger than the other.
Blow the ends
Well, it
out.
was twice as big as it, yeah.
Yeah, well, which one on your
Radial
pressure
windows.
tank was the high stress? The high stress was in the cylindrical part, right? That's not the part that's blowing the end off, so it's the hoop stress. The hoop stress is the one that's twice as big, right? So the stress going this way over here is twice as big as the stress going this way. So we cut a great big hole in it. What happens? Well, at these ends, there's nothing pulling on it. Right? Nothing pulling out this way because there's a great big hole here. So what happens after the stress that's coming in from here? It has to go around the window and then come back together over on the other side. Right? The stress has to flow around. The load has to flow around the window. Right? Is that making some little bit of sense in there? Right? It's got to flow around the window. So what does it do here? Well, there's no way to load it. Right? We're not, I mean, there is a stress this way, right? That's going down, which is down over here. And it doesn't vary, well, it does vary a whole lot, it varies by a factor of 10, right? And that's the end going off this way, but the one going this way is the big one, right? So what do we see? We see higher stresses over here. Where do those come from? Those come from, there's a hole there. Right? There's a hole in the window there, right? Okay. Blowing that up, is that making some sense? Right? The stresses have to, the load has to go around the window. Now, if you put another window right next to it, it gets worse, right? Right? Because what do? We don't have as much room to carry that, right? Okay. So then we start going, oh, grumble, grumble, grumble. Let's not put windows in the aircraft. Cameras. Keep Bashara happy here. Right? Okay.
One day we'll make them out of glass, fly like Wonder Woman. No more of them. That's a good idea.
Make the whole plane out of glass, right? Then we just, the whole plane, right? Plastics, that's the future, right? Hey, you've already got the plastic plane out there already. It's in the closet. Potato.
CFRP.
It wouldn't be held together without the plastics in it.
I know.
Right. All the polymers in
All the
there.
polymers are all
Yeah,
plastic.
well, you can say they're all hydrocarbons, right?
And
And that one really is hydrocarbon, right? Okay. It's just sometimes there's no hydrogen on it when they call them fibers, right? So, okay, sometimes they're just carbon, and the other times there are. Okay, so anyway, we got stresses in here. We can obviously go put, and it might be a good idea to put some additional mesh control in these areas around here just to see what it is. I wouldn't put as much of it, but you certainly can put it. And we're looking at stresses here. We got 30.4. What's the stresses out in the area? Well, you could probably go figure out what the stresses are out in the area if you wanted to, out in the field, where they are away from the window. We certainly can get far enough away from the window for the stresses to go down. Does make an interesting pattern, right? Gets hot around the edges and then, but very much maximized right there in the corner, right? And we do happen to have a lot of nodes in there, so at least I have a little bit of faith in that. I might still squeeze them down to 100 thou, put some more nodes in there. right? Smooth them out a little bit, get that stress concentration down. Because it looks like it's like one layer thick in there, right? So, hey, well, more mesh control. Okay. Oh, I didn't want to do that. I wanted to edit the mesh control. If 20 thousandths is good, how about 120? Even better. See, now we get even finer down there, and we can push on that even closer, but these are like an 1/8 of an inch apart there, right? It's pretty small, and as the radius gets bigger, they won't get bigger. Now, I wonder if it'll run with the large displacement flag off. We can try. See if it'll run with the large displacement flag off. No, it doesn't like it. Be interesting to see where it is displacing. I suspect it's displacing around the window, but I don't know that for sure. So we get that. If you make the nodes smaller and smaller and smaller, what you'll find is that just gets more and more concentrated. It did change quite a bit. It went from what, 400 to 417, so it increased by what, like 5%, just by changing the mesh size, right? So it's not quite converged yet, but it's getting pretty close in those corners there. Yeah, let's look at where what's the displacements are. Well, I'm not sure why it's complaining about large displacements when it's only displacing 160 thousandths. And even that one I think is only at this corner. It's just not displacing that much. Oh, I know what it's doing. That's right. Yeah, I know what it's doing. It shouldn't be doing that, but it is. It's so thin, it's doing that. Yeah. What's happening? There's an interesting pattern in here. Where are the big displacements? They're at the top and the bottom. So that's the big, they're not very big, right? They're only a little over 1/8 of an inch. Right? But what's happening? Well, as the thing pressurizes, what's it doing? Instead of swelling up evenly, it's flattening out. Okay? Right? And as it flattens out, what does it do? As it flattens out, it goes from being curved to being flattened out, and that's, well, yeah, that's what it's doing, right? We can argue about why it's doing it. Now, a couple different, if we worried about it, we might play with it. One of the things we could do is we could try to model more of it. We could try to get where we had 90 degrees and put different kinds of constraints on it, or we get to where we have 180 degrees and put different constraints on it, right? Get way away from that. That may help a little bit. Another thing that happens, and a lot of this is another alternative I've always had is and I've oftentimes done this with these pressure vessels, is you go, when did we do this? We replaced the pressure with a force, right? Well, what if we did the same going the other way? What if we just fixed one of these ends down there and put a force going that way? Could we do that? Yeah, instead of having the pressure that we did. Now, the problem is if we do that right now, what's it going to do? We're pulling over there, we're fixed over here, it's just going to flop this whole thing down. So what we need to do is we need to make sure it maintains its curvature. And the way we have it maintain the curvature is you just fix it in the radial direction. You say, hey, you can't move in the radial direction, you will be curved. Right? We can pull it and stretch it along that arc, but we can't pull it in the we can't move it in the radial direction. Basically, it's the equivalent of pulling it over a form, like a cylinder shape we're pulling on the material two different directions over a cylinder shape, making it maintain that shape with the constraints. And I've done that in the past. That actually works pretty good if you get tired of the large displacement thing, makes it go away. Now you can get the same. You have a little bit of trickiness calculating the forces, but you guys can do that. You know how wide it is. You know what the forces are. You can do some statics. I have faith.
You just totally remove the pressure then.
Yeah, you got the pressure, half of a cylinder. What's it trying to blow it apart? I mean, it's right.
Oh, so
I can't. I'm trying to trip myself. We just look at a cylinder, right? We cut it in half, right? What are the forces here and here, right? Well, you got the pressure in here, right? All sum P. What's it gonna do? All the ones that are going vertical are gonna, or vertical or horizontal, are gonna cancel out, right? For every one that's got a vertical component here, there's another one over here with a vertical component in the opposite direction. So what do? You get the width out of the board times the diameter. That's the area that it's acting on. That gives you a force, right? And it's split equally between the top and the bottom. And furthermore, it doesn't matter where you rotate this, right? You can rotate this split in here anywhere, right? So the force is always the same. In fact, that's how we got the formula in the first place. Okay, so now what we can do, after we get these, we can calculate the stresses in them, find the stresses in there. We hopefully know what the nominal stresses are out in the skin. And then we can calculate a stress concentration factor. And you've got a stress concentration factor and an R over W. Okay. And then what do you do?
Make a curve,
Well, you're gonna make a graph.
the graph.
So you're gonna have to have
So
more
when
points. Right, so how are you gonna get more points?
Keep changing.
You gotta go change the radius, right? Second verse, same as the first. Could be louder, probably worse. Yes, okay. If I start singing in class, you guys are allowed to protest to